Boxing Day, 2004. The world was shocked by one of the worst natural disasters of all time. Over 250,000 people died. The cause of this devastation was the most powerful kind of earthquake on the planet, called a megathrust. This event made us realize how poorly prepared we are to face these huge geological catastrophes. And scientists are now trying to work out where else is at risk. They have discovered that a megathrust as large as the Sumatra quake could hit North America. Everyone knows that America is going to be struck by a devastating earthquake. For years, the people of California have been waiting for the day when the San Andreas Fault unleashes the big one. But all the time, an even more powerful hazard has lain undiscovered. A giant megathrust earthquake, just like the one that hit Indonesia, threatens America's Pacific Northwest. A huge area from Northern California all the way to Canada is at risk, including major cities like Seattle and Vancouver.
It's a major earthquake.
We're just coordinating the emergency response that's going on.
The authorities have started to prepare for this catastrophe. Rehearsals like this one help to train the emergency services to deal with such an event. Children are now being taught lessons in survival that could mean the difference between life and death. The source of all this danger, lying underwater off the Pacific Northwest coast, is a huge gash in the Earth's crust, a subduction zone. The Earth's crust is made up of huge plates of rock that are constantly in motion. Where two of these giant plates meet head to head, one of them can get pushed down under the other. This is a subduction zone. It was a subduction zone off the coast of Sumatra that caused the Boxing Day earthquake. And worldwide, there are many other similar faults.
There are subduction zones all over the planet, but mainly they occur around the rim of the Pacific, the so-called Ring of Fire, and lots of big earthquakes occur there, most of the world's really destructive earthquakes.
Subduction zones cause earthquakes when the plate that's being pushed down gets stuck. As it pushes, the upper plate gets squeezed and distorted. Eventually, the strain becomes too much. The upper plate slips, creating a megathrust earthquake.
A megathrust earthquake happens when the subducting slab, which is diving under the overriding plate, is locked and causes the overriding plate to bulge upward. And then when that becomes unlocked, it slides suddenly, creating a huge earthquake. Worldwide, these are the biggest earthquakes. They range in magnitude up to 9.5.
Generally speaking, if you have two great masses of rock and you're scraping them one underneath the other, they're not going to move very easily. You're going to get a lot of friction there. And I liken it to sort of two cheese graters pushing past one another. Very, very difficult to get any smooth sort of movement there.
But as the 26th of December showed, megathrust earthquakes have another devastating consequence.
In the case of a megathrust earthquake, the overlying plate, which has been bent, pings back upwards into position. And it's that sort of pinging motion that transmits an enormous amount of energy to the seabed, That energy is then transmitted to the water above it, which oscillates up and down and then moves out as a series of huge ripples. And that essentially is what a tsunami is.
A tsunami is very different from a normal wave. In normal waves, only the water on the surface is moving. But a tsunami involves the movement of the whole water column. Millions of tons of water.
Normal wind-driven waves have very small wavelengths. That's from crest to crest. So there may be only a few tens of meters and then the wave has crashed and it's gone. Tsunami have wavelengths that can be hundreds of kilometers long. So when that initial wave comes in, the water behind it is pretty much at the same level, and that can keep coming for 5 or 10 minutes as a huge flood. And that's why they're so destructive. It's not a simple wave that you can hold your breath under and survive.
The combination of massive earthquakes and tsunamis makes subduction zones a deadly geological hazard. And so it should have been a cause for concern that the Cascadia subduction zone, a 600-mile-long fault, lies right off the Pacific Northwest coast. The strange thing was, Cascadia didn't seem to be a danger at all. For years, scientists had been monitoring seismic activity along the Cascadia subduction zone. They found that, unlike other subduction zones, it was virtually silent.
People saw that Cascadia had many of the features of a subduction zone. It had an oceanic trench, it had a line of volcanoes above the subduction zone. It simply didn't seem to have big earthquakes, and so they put it in a category of its own, the subduction zone that doesn't have big earthquakes.
And there was a simple explanation for why Cascadia wasn't creating earthquakes. If the plates were moving smoothly past each other, there would be no strain being built up, and no earthquakes. This theory was backed up by over 200 years of historical record. For as long as the Europeans have lived here, there's no record of any significant earthquakes from Cascadia. But in this region, there is another kind of history, a kind that isn't written down. For centuries before the Europeans arrived, this land was home to native peoples. Villarebi is a member of the Hoh Nation on the northern Washington coast. As a child, she was taught the legend of the Thunderbird.
The Thunderbird lives in the glacier at the headwaters of the Hoh River. When he comes out, the ground would start to shake, and he would even make the waters troubled.
Could this legend be describing a real event? A megathrust earthquake that occurred long ago. Most geologists had no time for such speculation, but one decided to take a closer look. Brian Atwater wondered whether the native legends might be a warning that the Pacific Northwest could be at risk from giant earthquakes. So he took to his canoe and started exploring the marshes and rivers of the Washington coast. He was hoping that the layers of mud here, laid down over centuries, might provide a clue to the events of the past. And buried in the marsh, he did find evidence of an unusual event.
We're on an ordinary coast, standing on a salt marsh like this one. Underneath, we find salt marsh deposits, salt marsh deposits, salt marsh deposits. just steadily on down.